One last note for task 4.2, solving rational equations. Just like logarithms, you're going to see this word extraneous solutions. Some of your solutions are what we call extraneous, meaning not all of your solutions are going to be valid. Some of them don't actually work. So let's look at rational functions and think, why might something fail? Why might something not be allowed in a fraction? Well, there's only one thing that makes our fractions undefined, and that's a denominator that equals 0. We can't divide by 0. So just like logs, we had to make sure our logs weren't negative. Here in our fractions, we have to make sure our denominators are not 0. So what you're going to do is you're going to check your solutions. You're going to solve an equation. You'll maybe get 2 answers, sometimes even 3 answers. And you're going to want to check your solutions. If any of your solutions make the denominators in the original function equal to 0, it is not a valid solution. So let's take a look at example number 6. In example number 6, you were asked to solve this, and hopefully you did solve it and solve it correctly. Let's pretend that we solved it and we got 3 separate solutions. Let's say we got the solution x equals 1, x equals 0, and x equals negative 1. Now, our last step is to check these solutions to make sure they do not make any of the denominators equal to 0. So we're going to plug them back in, and I'm going to plug them back into just the denominators. And I want to make sure none of them are equal to 0. So when I plug back in 1, I have 1 minus 1. That equals 0. So right off the bat, I cannot use x equals 1 as my solution because that very first denominator is 0. Now I can check the other 2 denominators and see that, well, the other denominators are going to be 1, which equals 1, and 2 times 1, which equals 2. But because this first denominator didn't work out, this solution is not actually a solution. Let's try 0. 0 minus 1 is negative 1. That one's okay. 0, well, just equals 0. So that means in this term right here, we would be having 3 divided by 0. That doesn't work. And even in this term right here, 2 times 0 is 0. So I would have 5 divided by 0. That one doesn't work either. Now, because those don't work out, I cannot use the solution of 0. I can't use it. Let's try our last solution, and let's make sure that it does not make our denominators equal to 0. So negative 1 minus 1 is plugging into that first denominator. Negative 2. We're good. Negative 1 is just negative 1, so when I plug into this one, it's going to be 3 divided by negative 1. We're good. We can do that. That doesn't make our function undefined. And then 2 times negative 1 is just negative 2. So this term right here would be 5 divided by negative 2. So yeah, we're good on that front too. Negative 1 does not make any of the denominators equal to 0, so we don't have anything that's undefined. And we can go ahead and say that negative 1 is an actual solution to the equation. So my hint for you on this one is that if you didn't do number 6 already, there was a second solution. Negative 1 is one of 2 solutions. So try that again, but on all of your rational equations going forward, make sure your final step is to check your solution. Anything that makes the denominator equal 0, we cannot use. It is not a valid solution.